Hope all of you are doing well. In the previous video, we have discussed NCERT text back exercises and its solutions till question number 5 from chapter Motion of grade 9. In this video, we are going to discuss the solutions from question number 6 onwards. Now we can move to the first question. Page number 112 and question number 6. Figure 8.11 shows the distance time graph of three objects A, B and C. Study the graph and answer the following questions. In this question, the distance time graph for A, B and C are given. By using the graph, we have to answer the following questions. In the graph, we can see that the distance is taken along y-axis, the values in kilometers, and the readings are 0, 4, 8, 12 like that. And in x-axis, the time is taken in hours. And the readings are 0, 0.4, 0.8, 1.2 and 1.6. Now the graphs for A, B and C is drawn here. The questions are A. Which of the three is traveling the fastest? B. Are all three ever at the same point on the road? C. How far has C traveled when B passes A? And D. How far has B traveled by the time it passes C? Here the answers are given, but we have to study it in detail so that we can consider the questions one by one. Now we can start with the first question. What was the first question? Which of the three is traveling the fastest? So in order to answer the question, we have to find the speed in each cases. Right, how we can find speed from a distance time graph? We have studied that speed is equal to distance divided by time. So how we can find from the graph? Here, if you are taking the slope, what we will get? What is slope? Slope is equal to y by x, right? If you are taking slope from this, what we will get here? Distance by time we will get. So that is speed, right? So for each cases, that is for A, B and C, we have to consider any slope and calculate y by x. That is the slope. Then we will get the speed in each cases. Therefore, speed is equal to slope of the graph. That means greater the value of slope, the speed will be more. But whenever we are calculating the slopes in the three cases, the slope of B is greater than A and C. That means B is traveling the fastest. Now we can consider the second question. Question is, are all three ever at the same point on the road? So that if they were in the same point, what will happen? They should intersect. That means all the 3 points should intersect in the graph. But all three objects A, B and C never meet at a single point. What does it mean? They were never at the same point on road. Now we can consider the last two questions. That is, how far has C traveled when B passes A? And how far has B traveled by the time it passes C? From the graph we can see that along y-axis in between 0 to 4 there are 7 small boxes. So what will be one small box? That will be equal to 4 by 7 kilometers, right? Because along y-axis the distance is given in kilometers. When we consider object C, we can see that initially the object was 4 blocks away from the origin. Also we know that each small box is equal to 4 by 7 kilometers. So what will be the initial distance of object C from the origin? That will be equal to 4 into 4 by 7. Right, that will be 16 by 7 kilometers. When we consider the diagram, we can see that at a particular point the objects A and B meets at a single point. So that at the same time, we can look into the object C also. So what was the reading of distance along y-axis? So that we can see as 8 kilometers. We can look straight into the y-axis so that the distance of object C from the origin when B passes A is equal to 8 kilometers. Page number 113. Question number 7. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? Here the height or distance is given and acceleration is given as 10 meter per second square. That is uniform acceleration, and we have to calculate the final velocity and the time taken. So which equation we have to use? Here it is uniform acceleration, that means we have to consider equations of motion, right, so that we can find the equation to calculate the values. Let us assume the final velocity as v and time taken as t. And it is given that initial velocity is u equal to 0, distance or height, that is s equal to 20 meter, and the downward acceleration a equal to 10 meter per second square. We have to select the appropriate equation from the three equations of motion to calculate v. Okay, what are the three equations of motion? We have v equal to u plus at, s equal to ut plus half at square, and 2as is equal to v square minus u square. So it is better to write these equations in one side and then select the appropriate equation, because we have u, a and s. Now we want to calculate v. Then which equation we can use? We can use the third equation of motion, right? That is 2as equal to v square minus u square. So from that equation we will get v square equal to 2as plus u square. Then we can substitute the values, that is v square equal to 2 into a is 10, so into 10 into 20 plus 0, because u equal to 0, that will be 400. Therefore final velocity v equal to 20 meter per second. Now we have to calculate t. So for finding t, which equation we can use? Again we have to find the appropriate equation from the three equations of motion, right? So that we have u, a, s and v. Then we have to calculate t. So which equation will be better? The first equation, right? That is v equal to u plus at. When we rearrange the first equation, we will get t equal to v minus u by a. Therefore, time taken by the ball to strike will be equal to, substitute the values, that is 20 minus 0 divided by 10. So that is equal to 20 divided by 10, that is 2 seconds. Now question number 8. The speed time graph for a car is shown in figure 8.12. In the figure we can see that along x-axis time is taken in seconds, and along y-axis speed is taken in meter per second. The first question is A. Find out how far the car travels in the first 4 seconds. Shade the area on the graph that represents the distance travelled by the car during the period. Question B. Which part of the graph represents uniform motion of the car? In this question we have to find out the distance travelled by the car in the first 4 seconds, and we have to find the part of the graph that represents uniform motion of the car. Here we can see the shaded area, that is from 4 to 6, that is 4 along x-axis and 6 along y-axis. So that will be equal to half into 4 into 6, that is 12. That represents the distance travelled by the car in the first 4 seconds. Here we can see the part of the graph with the uniform motion, that is marked with the red color. That is the part of the graph in red color between time 6 second to 10 second represents uniform motion of the car. Now we can conclude our video. The rest of the questions will be discussed in the next part. And if you like my videos, please like, share and subscribe. Thanks for watching.